So it says which statements are consistent with Rutherford's nuclear theory as it was on only, I think it's cut off here. Can I, nope. Let me see if I can, maybe I'll download this file and see if I can actually read the question here. Give me a second. Yeah, so it says which statements are consistent with Rutherford's nuclear theory as originally stated, why? And we have 4 of these guys here. So it says the volume of an atom is mostly empty space. The nucleus of an atom is small compared to the size of the atom. Neutral lithium atoms contain more neutrons than protons, and neutral lithium atoms contain more protons than electrons. So let's look at C and D first, because this is looking at lithium atoms. So let me draw out a lithium atom here. So I know a lithium atom. I have a lithium atom here. And how many protons does lithium have? Well, I can look at my periodic table and see that lithium belongs in number 3, right? So my atomic number is 3, so therefore I have 3 protons here. Which means this has 3 protons. And in a neutral atom, I want to balance out the charges, right? So I have 3 pluses, which means I'm going to have 3 electrons in a neutral atom. And how many neutrons would I have? Well, in this case here, 6.94 is a lithium, is my atomic mass for lithium. I can kind of round this to kind of 6.94 is about 7. So I can say that my atomic mass is 7. So I can say the number of neutrons, I know that neutrons is going to equal my atomic mass minus number of protons. In this case, my atomic mass, I'm going to round to 7. I'm going to minus 3 here for number of protons. So my number of neutrons is going to equal 4. So in this case here, for C and D, neutral atoms contain more neutrons than protons. So this one is, this C is correct, but is it consistent? We don't know. Number D here says neutral lithiums contain more protons than electrons. This one would have to be false. So we know that off the bat, D here is false. Now let's look at number A and B. Now A and B is the volume of an atom is mostly empty space, and this statement is true, right? Because the volume of an atom is mostly empty space. We have the nucleus, which is the biggest part of the atom, and then we have orbitals or electrons that are surrounding the atom as well. And it says B here, it says the nucleus of an atom is small compared to the size of the atom. This here is false, right? Because then the nucleus atom actually makes up most of the size of the atom here. So if B, we know that B and D are false, so we're just looking at A and D here. And both these statements are true, but which one is actually consistent with Rutherford's nuclear theory as it was originally stated? So what we want to do is we want to figure out, okay, what the heck is Rutherford's nuclear theory, right? So we want to say this kind of is the gold foil experiment if you're not familiar with that. And let me just look at let me just summarize what the nuclear foil experiment did. And basically what he did was he put kind of a it might be better if I actually gave you a diagram instead of me explaining it. So let me just Google this and Rutherford's gold foil experiment, and let me see what we can do here. I just want a diagram basically. No, that's not a very good diagram. This one? Nope. Let me see this one here. So I kind of like this one. This one's actually pretty clear. So it says here, I have like some type of screen here, and I have an alpha particle emitter. And what it's going to basically shoot out alpha particles onto this gold foil. And we have screens that are surrounding this gold foil. So basically what we're doing is, or what Rutherford was trying to explain here, was that most of the alpha particles go through the gold foil, which is what he proposed before. But he also saw that the detecting screen, he also saw that there were alpha particles that would reflect off the screen onto multiple angles here. So this here is the arrow or the rays that you see bouncing off this gold foil. So as you can see, B here is most of the alpha particles go through, but some of them actually reflect onto different angles here. So knowing that, it means that his conclusion here basically states that most electrons go through, which means the volume of an atom is mostly empty space, right? Because most of the alpha particles are going to go through, and alpha particle compared to atoms are much bigger than those ones as well. But the ones that are being reflected, it means that they're actually hitting the nucleus of the atom here. And as you can see, this here is the nucleus of the atom, or the electron in this case here. And some of them are going to reflect onto different angles, right? So those are my conclusions of here. And as you can see, the summary here is good, right? It says bombardment of gold foil with alpha particles showed that some particles were deflected. So it means the nuclear model of the atom consists mostly of small, dense, positively charged interiors surrounded by a cloud of electrons. So therefore, what we can say about the statement here is that A is true, right? The volume of an atom is mostly empty space because most of the alpha particles are going through the gold foil here. So A will be our correct solution in this case. And let's see. I don't know. Oh, it says answer. The statement of volume is mostly symptomatic is consistent with Rutherford's theory. So this solution here is correct. And let me see if they have an explanation here in the text here. So it says, according to Rutherford's nuclear theory, most of the space in the atom is empty and tiny negatively charged electrons are dispersed throughout the volume of the atom. Therefore, the statement is true. So solution is correct. Good analysis. So you can say that Rutherford's gold foil experiment concluded that the size of the atom or the volume of the atom, the volume of an atom is mostly empty space because most of the alpha particles, and they're big compared to the atom, went through the gold foil. So this solution is correct and is good analysis as well.